I said everything gonna be alright. I said everything
it's all gonna be alright. Good day wherever you're listening from, and welcome to Indoor Air Quality Radio, IAQ Radio. It's Friday, May 6th, 2016. This week is episode 413. My name is Radio Joe Hughes. Here with me in the Studio D at the controls is our engineer, John. You gotta have faith. And joining us from Studio C back in McKees Rocks is the Z-Man, Cliff Zlotnick.
Good afternoon, Joe and John. Hi, everybody.
Good day, Cliff. This week we've got Dr. Brett Singer from the Lawrence Berkeley National Labs. But before we get started, we can't do the show without our sponsors.
John Don Products, where restoration and abatement contractors shop. Visit them at their website, jondon.com. That's jondon.com.
Clean Facts, the #1 information source for cleaning and restoration professionals. Check them out at cleanfactswithanx.com.
IAQ.net and Healthy Indoors Magazine, a free online digital magazine for industry professionals and consumers. Subscriptions are available at IAQ.net.
And Particles Plus. They are engineers and manufacturers of feature-rich particle counters, air quality monitoring instrumentation, and vacuum pump technology. ParticlesPlus.com. Count on us.
Please be sure to thank our sponsors for their support of IAQ Radio when you inquire about their services and products.
And last but not least, please visit the IAQ Training Institute website for the most current dates for the training you trust at IAQtraining.com. All right, let's turn it over to the Z-Man for today's IAQ Radio trivia question.
Thanks, Joe. Win a cool prize by outcompeting fellow IAQ Radio listeners and being the first person to correctly answer the IAQ Radio trivia question each week. Submitting your answer is easy. Either email it to czalotnick@cs.com, or if you're listening to the show live, you can text in the answer via your computer. Congratulations. To Andrew Gunzar, Certified Safety Consulting in St. Louis, Missouri, for the first correct answer to last week's IAQ Radio trivia question. The trivia question for Friday, May 6, 2016, has been sponsored by Ideas LLC, the solution chemistry company creating unique solutions to odor removal, surface cleaning, and decontamination problems. Now for this week's IAQ Radio trivia question. Name the scientist at the University of California who created the model of how large-scale science should be pursued. Back to you, Joe.
Okay, we've got Dr. Brett Singer with us today. He's the group leader of the Indoor Environment, Energy Analysis, and Environmental Impacts Division at Lawrence Berkeley National Laboratories. He's also, the Principal Investigator in the Whole Building Systems Group in the Building Technologies and Urban Systems Division. He conceives and leads research projects related to air pollutant emissions and physical chemical processes and pollutant exposures in both outdoor and indoor environments, aiming to understand real-world processes and systems that affect air pollution exposures. We've got some music for Dr. Singer.
Science is awesome and I love it so. There's still lots and lots of things science don't know. There've been major discoveries throughout history, but this universe of ours is still one great big mystery.
Okay, I like that one, Cliff. All right, Dr. Singer, do we have you on the line?
I'm here.
All right, great to have you with us. Met you more formally. I know we met somewhere along the way at the PM 2.5 workshop in D.C. By the way, for listeners, I put the link to the website from that workshop in the show announcement and in the links at the bottom of the show announcement, because all the papers are up now. They have videos from that conference. It was a great conference. And I'm wondering, with respect to research, how did you first get started and interested in research?
Well, first of all, let me thank you for having me, and happy to answer that question. I actually started in outdoor air quality, and I got an interest from, like many people, personal experience. I was going to college at Temple University in Philadelphia, which is in slightly north of the downtown part of the city, and I was living in the west part of the city, and I had a bike across the center of the city to get back and forth to school every day. And I noticed that biking home through afternoon rush hour traffic, by the time I got home, I'd feel a little lightheaded every day. And I said, that doesn't work out so well. So I started figuring out that was the air pollution from all the vehicles that I was breathing in, and started out working on vehicle emissions as my graduate work at UC Berkeley, University of California, Berkeley. And then while there, I met one of the true greats of indoor air quality research, Dr. Bill Nazaroff from UC Berkeley. And he helped advise me as a graduate student, and then when I finished there was a project that he had on secondhand tobacco smoke, and it was with some researchers up here at Lawrence Berkeley Lab. Dr. Joan Daisy, who's unfortunately no longer with us, but another truly great researcher. And I came up to Berkeley, up to the Lawrence Berkeley Lab to start working on secondhand smoke. And I'll tell you a little bit about that if you're interested. But that basically got me going on this course. And I still dabble in outdoor air quality occasionally. Certainly it's very important to indoor air quality. But I've mostly been working on indoor air quality since coming up to the lab, and that was in 1998.
And, we commonly do shows. We call these the research to practice shows. We've got a lot of practitioners, both remediation people, consultants that deal with indoor air quality issues. And I guess what is the most important thing for these indoor environmental quality professionals to understand when it comes to choosing the type of research they should, grasp and make part of their practice?
Oh, that's an interesting question, and I'm always reluctant to say the most important thing, because I think it really varies. Certainly, when you're out there working with clients, I think the most important research is the research that's relevant to the client you're working for right now. I know when I go to the doctor or consult a professional about something related to my health, I'm interested in what they know about that. So I think mainly it's I'd say that the overarching message I would say is there are many great resources out there. And I know a lot of practitioners make use of those resources because they're calling me all the time and my colleagues, and I think that's really great. And they know they go to our websites, but there really are lots of resources. Certainly the scientific literature, our job as professional researchers is to try to publish our research, put it out there in the public sphere in a way that demonstrates that it's high quality and basically true and accurate. And then, so accessing those journal articles is sometimes a good idea. It's certainly good as the kind of ground truth, but there's also many resources that are available to translate that research into kind of usable nuggets. When we do work here in our group, we really try to do that right there in the scientific paper, but I know that we're not always as successful as we would like to be, and I know my colleagues try also, but sometimes it's really helpful. EPA, the U.S. Environmental Protection Agency, has an Indoor Environments Division that does a lot of work of translating scientific research into practical information for both the public and for the professionals in the industry. The California Air Resources Board, and then there's lots and lots of sort of independent organizations that do that sort of thing. We have a scientific findings resource bank on the LBNL website, and I can give you that link as well, so you can post that up on your site for your listeners. So basically, I would say there's lots and lots and lots of research out there. It's not always directly applicable because you can't, preconceive of every question that can be answered. But I think there's a lot of really smart people working in this area, and I'm always really amazed at how well they are at translating the available research into practice, into the questions that they're facing. So I'd say, go out and search for those resources, and if you can't find them, then call the EPA and their Environments Division and ask them what's available, and call your state if you have a state health department or state agency. Try to look for the resources, because I think there's a lot out there.
You mentioned a lot of government agencies and groups that are oftentimes funded by government agencies, but a lot of the research or what people call research that practitioners will see might be in a trade journal or in a publication, and oftentimes it's sponsored by manufacturers of the equipment. When people see something like that, what should they be looking? I mean, obviously, we're going to have to be a little cautious when we're looking at.
Sure.
But what other things do we look for that are key things to look for within that research?
Yeah, and let me add something. There was a category of organizations I mentioned only briefly, but I really should call them out much more, which is there's groups like the Indoor Air Quality Association. That is an organization of practitioners. They put out a newsletter. They have annual conferences. Groups like ASHRAE that does a lot of work on indoor air quality. So these professional organizations are actually tremendously valuable resources. In fact, those two organizations, IAQA and ASHRAE, have just reams and reams of information available. Some of it's for good reason reserved for members, but if you're out there practicing, I strongly encourage that. There's National Environmental Health Association, the American Institute of the Association of Industrial Hygienists, American Industrial Hygiene Association, AIHA.
Yep.
So professional organizations. Now, getting back to your question, I actually, as a scientist, I'd say I like to not prejudge anything. I like, based on who did it, I like to really assess the quality of the information based on what's presented and what was done. So when I see a scientific paper or report that was published by someone that was funded by whatever, the tobacco industry even, okay, so a lot of people will just write that off, and I think that's sometimes unfair to the people who do the research. I would look at it with a discerning eye and take that into consideration when reviewing it, but I wouldn't necessarily reject it. That being said, I think when you're looking at research that is put forward by a commercial interest, somebody who really stands to make or lose money based on the outcome of that, I think you have to be incredibly skeptical. It doesn't mean you necessarily reject it, but you just have to recognize that the people who sponsored that have an interest. So I think that casts a little bit of a shadow, and certainly it should raise everyone's skepticism. And so when you're looking at those results, ask yourself, okay, what did the people who paid for this stand to gain from these results? Who did the research, right? So if it was paid by the Candle Makers Association, okay, for example, but the research was done by professors at let's say Harvard or Stanford or some highly reputable research institution. Those professors are probably not going to sell their reputation for the cost of one research project, mm-hmm. right? So then you might say, well, yeah, sure, the candle makers, but maybe it's right, and the reason the candle makers had to fund it is because no one else was going to fund it, and this researcher from Stanford is not going to put their reputation on the line for being able to do one research project, right? Their reputation is worth a lot more than that. So I'm going to give it a read and see if it makes sense. But if it was done by some consulting firm that you've never heard of, and you don't have any independent sense that they're reputable or honest, then I would be skeptical. And I think I've seen both of those cases, right? I've seen industry-sponsored research that's actually very good, and I've seen, unfortunately, a lot of industry-sponsored research which clearly had an agenda.
And how important would it be in most cases to have some kind of control while you're doing a study? I mean, I've seen studies where there was, results and claims made, but no control to really, help us determine if that claim was the result of what they were studying or not.
Yeah, that's an excellent point, and it's one of the things that we look at kind of from the scientific methods, good study design, right? So you measure something happening in a home where something has been done to that home, and the natural inclination is to say, well, it must be this thing, but it could have been any number of other things. So the way we do that is we control. So I'll give you some examples we'll give you one example from our own research. So we're interested in the question of whether controls for formaldehyde in homes. Formaldehyde is a respiratory irritant and a carcinogen, and still a lot of uncertainty about what the safe level is, but there's certainly a big prerogative to reduce formaldehyde levels. They used to be much higher. We used to put it's a byproduct of insulation. We've taken it mostly out of the insulation, but there's still a lot of formaldehyde in homes. So we're interested in whether or not controls work. And specifically, the question was, do homes built with low-emitting materials, because you can buy low-emitting materials, have lower formaldehyde concentrations after they're built? Pretty straightforward question. In order to answer that question, though, we couldn't just go into some homes that were built with low-emitting materials and measure formaldehyde and compare that to formaldehyde measures in a random collection of other homes. Why? Because formaldehyde generally is higher in new homes versus older homes, because it basically outgasses or desorbs from the material over time. So we had to look at homes, the conventional homes that had not low-emitting materials, that were of the same age, okay? And when they're not exactly the same age, you have to adjust for that. And then it also turns out that the formaldehyde emissions vary with different seasons, because during the summer, your materials and your cavities heat up more, and then they emit more formaldehyde. So then we had to make sure that those measurements were done in the same season and the same temperatures. And then if you have higher air exchange rates in your house, more outdoor air exchange, you're going to dilute the formaldehyde more. So then we had to make sure that they were done with similar air exchange rates, and when they weren't, we had to make an adjustment for that. So these are all and there were some other factors as well. So in order to answer that relatively simple question, we had to control for other things that we know affect the formaldehyde concentrations. And I think, unfortunately, science is not so cheap. To do really good scientific research, sometimes you could do things kind of on the cheap, but for the most part, it takes takes an investment to make sure it's done in a way that is produces reliable and true results. So, and the difficulty is, we don't expect everyone to be a professional researcher any more than we expect everyone to be a physician or a lawyer or anything else, right? So people go to experts for this kind of knowledge. The practitioners, they have a lot on their hands to try to figure out how to apply the science to solving real problems. And as I said, there's a gap between what we do in the science sometimes and what the real problems are, so that they're bridging that gap. And they're also hopefully helping developing enough of the kind of sense that you talked about, Joe, where they're looking for the controls, or they're asking the questions. When they read a study, if you're a practitioner out there and you read a study, ask yourself, did they account for other things that could explain what they saw? Okay, what they reported, the outcome that they reported, did they look at other things that could have caused that, and did they control for those? And if not, then you should discount that research somewhat. It may still be right. It doesn't mean it's necessarily wrong, but it's not a reliable result that you should depend on.
Okay, and to go back to your example, how did the study turn out with respect to using the low-emitting formaldehyde products? Do they seem to be better?
Yeah, we saw pretty substantial reductions. I don't have the numbers in front of me, but I think they were in the order of 25 to 35% reductions.
Okay.
Formaldehyde levels with the low emitting materials. So it works. So go ahead and use those low emitting materials to reduce your formaldehyde levels.
Now that's formaldehyde, and let's I'll come back to that if we get time a little bit later. I'm curious, how does your group choose what projects, what type of research to work on?
That's a good question. So we try to figure out. And I work in a couple of different groups, so it's not the same in each group. But in general, we try to identify what we think are really important questions, research that will help the field move forward, help us in our general understanding, but also with a lot of practical implications. We try to figure out what are the uncertainties or unknowns in this field of indoor air quality that if we could understand them better, would help improve indoor air quality in real buildings, right? And in one of the groups is the residential buildings group, where we do a lot of work with the Building America program, Department of Energy's Building America program.
Okay.
And that's a research to practice program. So the Building America program supports both researchers, national lab researchers, and then they have a private sector and consortia that apply for programmatic grants from them. And then, but there's a big eye on practice. So that's a program that's really trying to provide the information that the industry and the market needs to advance to make better, lower energy, more durable, more comfortable, better indoor air quality homes, right? So they're not just trying to make low energy homes, they're trying to make great homes. And they're trying to give the industry the tools they need. So for that work, what we're trying to do is we're trying to say, okay, what are the problems that practitioners, builders, retrofit contractors are going to need solutions for 5 years from now, 10 years from now, right? Because if we want to give them, if we're trying now to solve a problem that somebody has now, then they're going to be waiting around for that solution, right? Because it takes some time to do the work. So we actually have to look forward and say, okay, if we're doing our job well, then we produce something, and then today and tomorrow somebody asks for that thing that we just produced, right? So I'll give you an example of that. We're building homes tighter. United States, America, we talk about making America great, right? Yep. Well, America's doing pretty well right now of building really great homes. The builders have stepped up to the challenge, and it's not uniform throughout the industry, but there's quite a number of builders who are building really fabulous homes right now, and they're looking for ways to build those homes even better. And they're looking to programs like Building America to tell them how to do that. So as we build these homes tighter, then the importance of providing mechanical ventilation becomes more important, right? So in the old days, we didn't need to put in an exhaust fan or provide constant mechanical ventilation because your home was like a sieve, so there's always air moving in and out. Now, that doesn't happen with new homes. So we build them tight, but then you have to ventilate them right. Now, it raises a question, how much ventilation is needed? Okay, ASHRAE has a committee, the ASHRAE organization has a committee that produces a ventilation standard for acceptable indoor air quality in residential units. And there's numbers that they have in terms of requiring ventilation. They do a really great job of trying to figure out what those numbers should be, but it's based on a lot of historical kind of continuity, and there's really good questions about what's the right number for the minimum ventilation rate. Can we provide ventilation at different times of day that maybe save some energy? Is that equivalent? What other kind of, if we control sources, can we turn down ventilation? Mm-hmm. For example, if you do particle filtration, then can you provide less outdoor air and still provide good indoor air quality? So we're working on trying to figure out a lot of those questions. To get back to your question, though, so we do our best to try to figure out what the questions are, but we don't have a set budget every year that we get just for being here, right? So we have to we have to convince government agencies, privates. We get money from industry. We get money from industrial groups as well. For example, we have to convince somebody that something is important enough for us to do the research, right? Where we have to convince the Building America program, hey, here's a set of questions that are really important for us to answer. And then the Building America program, they look at their research portfolio and they look at their research roadmap and they say, yeah, that aligns with what we think is important. So we're going to support you to do that research.
I see. Cliff, let me make sure you get a chance to jump in here if you have a question.
Thanks. What are some of the more important studies that have come out of LBL that people investigating and remediating indoor environmental quality issues should know about?
Oh, that's a good question, and I was going to answer the answers to the first part of that question may be more broad than the answers to the second part. So, and the second part of your question was that people who are doing remediation should know about, if I heard that correctly, and maybe I'll answer that one first, and then I'll go back to the more general. What are some important studies? Because there's some work that we've done that I think is important to improve our general understanding of indoor air quality. That's maybe a step away from the practitioner, but certainly going way back, our group's been doing research for several decades, and one of the early topics we spent a lot of effort on, well, there was formaldehyde for sure, but radon. We did a lot of work on radon, trying to understand how you control radon. So a lot of the radon control systems and assessments that we have now developed from work that we did, and we're very proud of that work. That was quite a while ago. We did a lot of work on secondhand tobacco smoke, so helping to establish how hazardous secondhand smoke is, leading into third-hand smoke. So I don't know if you two or your listeners are familiar with this term third-hand smoke, but this actually came out of that research I referred to earlier, where we realized what others had realized too, which was that the chemicals from tobacco use would actually stick around long after you were done smoking, right? So the example I always give is when you come home from the bar and you still smell like tobacco smoke. Now, thankfully, in lots of places now, the bars don't have tobacco smoke anymore because we've made restaurants and bars smoke-free in lots of places. But lots of places they do. So what happens when you come home smelling like tobacco smoke is you're carrying those chemicals back home with you. They stick to your clothes and your hair, etc. Well, the same thing happened in your house, right? So we had known for a long time that these chemicals you were basically coating your house with the chemicals from tobacco, okay? And there was a sense that maybe that wasn't such a good thing, but it took a while before we could actually identify kind of a smoking gun, if you will, of how exactly is this harmful. And it was our group here at LBL that found at least one mechanism. I think there's plenty more, where the nicotine that was sorbed to surfaces would react with a chemical in the air we called HONO, which forms, when that reaction happens, it forms something called a tobacco-specific nitrosamine. And the tobacco-specific nitrosamines are some of the most harmful chemicals in tobacco smoke. So then now we have a mechanism where the chemicals from the tobacco that are stuck to your walls and carpet and everything else are reacting with something that we know is in the air. And that HONO chemical gets produced, for example, by gas combustion. So when you use your gas stove, you'll get a lot of HONO. Comes in from outdoors. It's formed in some other ways as well. So that reaction sort of demonstrates a real established hazard from the sorbed nicotine, and with that, there's probably many other hazards, but that was one we were able to identify. So we're pretty proud of that. Done a lot of work on filtration. Again, something has been kind of ongoing for several decades. Filtration gets better, and we stick with it. Looking at a lot of work on productivity and health. So one of the big findings, a colleague of mine, Bill Fisk, he demonstrated that indoor air quality wasn't just a good thing for our health, it actually helps productivity. So workers are more productive when they're healthy and when they're not getting headaches and things like that from bad indoor air quality. And it turns out that the value of indoor air quality for productivity is tremendous, right? So there's a health benefit, but there's also this productivity benefit. So for offices and commercial spaces. And in recent years, we've done a lot of work with this residential building systems group looking at indoor air quality in very energy efficient homes. So, and we've shown through a number of studies that you can improve indoor air quality. You improve indoor air quality while you're making your home more energy efficient. So it doesn't have to be a choice. It actually could be a synergy. So you do both at the same time. And when you're doing these kinds of renovations or retrofits for energy efficiency, very often the indoor air quality improvements are not nearly as expensive as if you were doing them separately. So you just, by paying attention to both things at the same time, you can achieve both very cost effectively. So that's a little smattering.
Yeah, well,
too many to really go into all the details, but that gives you some sense.
Let me get just a little detail on the last one, and then we've got to break and thank our sponsors. So when we're improving the energy consumption in a home, at the same time we want to, and I see more of this, help improve the indoor air quality. Do you have any idea how many of the programs out there now are combining, using the combined approach as opposed to just worrying about energy?
Quite a lot, actually. So I'll give you a couple of examples. Starting with the Department of Energy's Weatherization Assistance Program.
Okay.
The Weatherization Assistance Program requires, as part of their package, that if you air seal a home tightly, then you want to give it mechanical ventilation that's consistent with the ASHRAE ventilation standard. So right there, it's kind of built into the program.
Mm-hmm.
The EPA, it's another of our sponsors, that Indoor Environments Division. They produced a really great document, and I'm going to get the exact name incorrect, but basically it's indoor air quality guidelines for retrofits. So when you do energy efficiency retrofits, there's a document that tells you all the things that you can look for to as opportunities to improve indoor air quality at the same time, and certainly to make sure that you don't make anything worse. And it's a very readable guide. They spent a couple years doing it, really high quality, and just a great resource for practitioners. They have one for single family, and then they have one for multifamily. And I can again, I give you the links to those because you should put those up on your website for your audience. Department of Housing and Urban Development, that it might be the biggest land management group property management group in the U.S. We work with their Healthy Homes, their Office of Healthy Homes and Lead Hazard Control, and they incorporate indoor air quality into their programs as well. So they have housing specifications for manufactured housing, certainly in a lot of their operational stuff. A lot of state programs. Another thing that we've done research on to contribute to and is done in programs is what we call combustion safety testing. Mm-hmm. So when you're doing an energy efficiency retrofit, you're air sealing a home, by making the home tighter, you potentially could make it more difficult for a natural draft appliance to establish draft. So one of the features that's very common in these energy efficiency programs is to make sure that you don't adversely affect the safety of the combustion appliances, right? So they go through a series of tests to make sure that the appliances will still operate correctly in this tighter home. So I think a lot of great things are happening out there, and there's a lot of people working in these programs, both on the public side and the private sector, who we go to conferences, and a lot of these are retrofit contractors. They're very attuned to this, and it's very important to them to make sure that they leave the home in a better condition for indoor air quality when they start.
And they are, much more interested, at least in my experience recently over the last few years, in making sure they include indoor air quality than they may have been 5 or 10 years ago. And certainly more so than back in the 70s when we first started tightening up buildings without any concerns, without enough thought about indoor air quality. I think we learned a lot of hard lessons back then, and it sounds like, from your experience, it's being, those lessons are being learned, and then when we bring out the new programs, they're built right in.
Yeah, there's still a lot of work to do. So I don't think our job is done. But I just want to call out, because again, we go to a lot of conferences where we are presenting to practitioners who are taking time out of their professional lives to come and learn and improve their education and knowledge. There's groups like the Affordable Comfort Institute, Home Performance, ResNet, again, the Indoor Air Quality Association. There's lots of groups that are that have conferences to help these professionals learn kind of state-of-the-art techniques and knowledge, and lots of people show up. 1,000 people show up to some of these conferences, many hundreds of people. These are professionals who are coming to learn how to provide this for their clients. So I'm always very impressed with how much they dedicate themselves. Again, not everybody, but there's a lot of people out there. So if you're, the message, if you have anybody out there who's just a homeowner listening to this, is if your contractor doesn't seem like they, know anything about indoor air quality or don't have a lot of concern about it, look around, because there are people out there who really are spending the time to figure this stuff out.
I think that's a great take-home message, and we'll get those links to Cliff so he can put them in his blog. But let's stop and thank our sponsors, and then when we come back, we're going to go into a little more detail on the PM 2.5 workshop and some of the things that came out of your presentation there. And thanks to our association sponsors, the Indoor Air Quality Association, a nonprofit multidisciplinary organization dedicated to promoting the exchange of indoor environmental information through education and research. Visit them at IAQA.org.
The Restoration and Specialty Cleaners Association, who have been serving the needs of and advocating for their members for over 30 years. Remember, Triska is your link to industry training, certification, standards, and events. Their website is prsca.org. Thanks to our advertisers.
Gray Wolf Sensing Solutions, who use advanced sensor technology and embedded computers to provide superior environmental test instrumentation. Visit them at wolfsense.com.
Legends Environmental Insurance Services, the experts in insurance for environmental consultants and contractors for over 20 years. Visit them at legends-enviro.com. And, of course, our marquee sponsors, John Donn Products, where restoration and abatement contractors shop. Visit them at their website, jondon.com. That's jondon.com.
CleanFacts, the #1 information source for cleaning and restoration professionals. Check them out at cleanfacts.com.
IAQ.net and Healthy Indoors Magazine, a free online digital magazine for industry professionals and consumers. Subscriptions are available at IAQ.net.
And Particles Plus. They are engineers and manufacturers of feature-rich particle counters, air quality monitoring instrumentation, and vacuum pump technology. ParticlesPlus.com. Count on us.
Please be sure to thank our sponsors for their support of IAQ Radio when you inquire about their services and products.
Okay, we're back for the second half of our interview. We've got Dr. Brett Singer from the Lawrence Berkeley Labs. And I wanted to go into, we had gotten a chance to talk a little bit at the workshop they had at the National Academy of Science. And it was 2 days of presentations on particulate matter and how particulate matter affects health, and how, what we can do to help, I guess, do a better job of making sure that particulate matter in indoor environments is not as much of a problem for people as it seems to be and has been. What was the big takeaway for you? We saw all these tremendous speakers. What did you pick up from that conference that you took back and thought, I'm glad I was there. I'm glad I listened to that particular presentation or that point.
Well, there's two levels. The most direct, honest question was, I'm always so impressed with how great my colleagues are at doing this work. In a lot of scientific fields, there's a lot of ego and a lot of people who really, think highly of themselves and their accomplishments. And in this field, so many people who are really just dedicated to what they're doing and trying to just make contributions, and really, really bright people who work very, very, very hard, and are just really committed to trying to make a difference and trying to provide useful information for the world. So that was my first take home. That might not be that relevant to listeners, although I'm sure they're glad to hear that. In terms of the content, there were several things. So I think first of all that we've really learned a lot about understanding the sources of particulate matter in homes, understanding the hazards of particulate matter, and also controls. Okay, so there's lots that we have learned. We probably, but there's still things we don't know. Certainly, we know a lot more about outdoor. A lot of what we know about particulate matter, the health effects of particulate matter, is based on looking at the results of higher concentrations of particles outdoors. So thankfully, we have a long record of EPA kind of designed or approved monitoring stations. The monitoring is actually not done by EPA; it's done at the state and local level. Okay, so it's for those people who are anti-federal government, it's actually a good model, because the EPA just kind of sets the guidelines for how the monitoring should be done, but then it gets actually done at the state and local level. But those data that we collect have been a really good investment for the public, because then researchers can go and say, okay, when particle concentrations outdoors get higher, what happens? Well, we see a lot more people show up in hospitals with a variety of adverse health outcomes, respiratory, cardiovascular, et cetera. So we can even see things like when there's higher particle levels, then what are the effects on fetal development, for example. So we look at the characteristics of the infants, okay, that are born from mothers who experience higher air pollution, and we're seeing more and more research in that area. So we know a lot about the health effects of outdoor particulate matter. It's interesting. We still the particles that get produced indoors are similar to particles that are produced outdoors, but not to the mixture. So the mixture you see indoors can be a little different, and there's still some uncertainty about that. In terms of controls, it really is possible to reduce your exposure to particulate matter inside your home. Your home, being in a building, affords you opportunities for controls that you don't have if you're living in a very open space, like a leaky building. It's a lot harder to control your particle concentrations. Still can do it, but living in a nice tight home, you really have a lot of opportunities to do that. Which begs the next question, right? Which is, well, how do you do that? Right?
Exactly. What are the
I was waiting
best...
for you to jump in with that question, but I'll just be asking myself.
Now, go ahead. What are the best, methods for reducing that exposure indoors? And
right.
Let's go into your presentation too a little, just so people know. You spoke about doing so in lower socioeconomic status households as well. So maybe we should start with the ones that just about anybody can afford.
Yeah, so I'll start broadly, and then I'll get to the low socioeconomic status. And broadly, this question comes up of whether or not it's good to air seal my house, to tighten up my house, tighten up my shell, because a lot of people like their houses to breathe, okay? Obviously every homeowner should make their own decisions. But I guess what I'm here to say is I think we know that we can make homes that are still safe and can even be safer and more protective. One of the advantages to air sealing your home is that you can better control the air coming into your home. You can control the rate at which it comes in, and depending on what kind of ventilation system you have, you can control the pathways. When you have a tight home, air comes into your house less rapidly, and so it sort of slows the rate of air from outdoors coming into your home, unless, of course, you want it to come in by opening the windows, which you can always do, right? Mm-hmm. And what that means is that when the particles come in, there are other mechanisms. They get removed from ventilation, right? But that's kind of a net zero thing. So if you bring something in from outdoors, you remove it with ventilation, so your indoor concentration over time will be similar to your outdoors. So carbon monoxide, if you don't have any carbon monoxide sources inside your home, over time the carbon monoxide levels inside your home will be the same as they are outside, because it's kind of non-reactive. It doesn't interact with your house. Particles are a little different. Particles actually will deposit on the materials in your house, so they get removed from the air through these passive means. Okay, and that puts aside filtration. So if you slow the rate at which you're bringing particles in from outside, then you will actually reduce your indoor concentration of outdoor particles. Now, we know outdoor particles are hazardous, so you reduce your hazard. Now, if you're perfectly healthy, you have no respiratory issues, you don't have asthma, you don't have whatever, it maybe isn't as important, okay? But if you have COPD or asthma or some other health condition, or you have young children in your home who have still developing lungs, then controlling that outdoor air pollution can be really helpful. And that would be both the particles, particulate matter, or PM 2.5. Diesel particulate matter is something that's outdoors we know is particularly harmful. Ozone, okay, is another one of these chemicals that will actually interact with the materials in your home. So by slowing the rate you bring it in, you actually reduce your exposure to ozone indoors. Okay, so that takes care of the outdoor part. But then the question is, well, what happens if I have a particle emissions indoors, right? Right. My concentrations are going to be higher indoors because I'm not going to ventilate them out as quickly. And that's true. So it means that when you have a tight home, you have to be more attentive to the particles that you're generating inside your home. So what are the things that generate particles inside your home? Well, cooking is a big one, okay? And before I say anything else, cooking is a good thing. I encourage people, if they can find the time, to cook their own food. It can be really fun. You can make really healthy food. You can make really tasty food. So we're pro-cooking, but you should be aware that when you're cooking, you are producing not just particles, but there are other chemicals that get produced from. There's a chemical called acrolein, for example, that gets produced from heating up oils. Okay, that is irritant chemical. So you produce these chemicals from cooking that can be harmful. So one of the things you can do is that when you're cooking is to use a good kitchen ventilation system, preferably a range hood that's over your stove. And I recommend you start the range hood before you start cooking, so before you turn your burner on, and then let it run for maybe 5 minutes after you finish. And if you can cook on your back burners, then your range hood's going to be a lot more effective. You don't have to always run it on high. If you're just doing simple, you're boiling some water or cooking you're heating something that's going to just heating some sauce in a pan or something. Maybe you leave it. You put it on the back burner. You turn your range hood on low, and maybe it's good enough. But if you're cooking a 2 or 3 burner meal, then you want to put your range hood on high if you can. Again, make sure that it's actually venting to the outdoors. If your range hood's not venting to the outdoors, then you want to increase the ventilation through some other exhaust fan or opening a window. So we want you to cook, but then just make sure you take care of those pollutants when you do it, and then enjoy the food. Candles is another big source. Candles and incense, right? People like to burn candles and incense, but they should realize they're producing a lot of these fine particles There's not a tremendous amount of research. In fact, there's very little research on the kind of the harmfulness of the particles that are produced from candles and incense. But I think the precautionary principle would say we know that other particles of those sizes are generally harmful for you. So until there's research showing that candles and incense particles are particularly non-harmful, you should assume they're harmful. So, if that's something you like doing, then maybe you want to be operating an air filter, or and you can get some very quiet air filters to take care of those particles. A lot of times you're not going to want to open a window or a couple windows when you're doing that because you're trying to create atmosphere. But just be aware that this is something that is producing particles that can be harmful to you. So try to have some control. And then there's all kinds of other stuff like, generally anything where you're burning something is going to produce a lot of particles. So obviously people know cigarette smoke, but pot smoke, if you're into that sort of thing, then and not to mention the primary smoke, right? So if you're smoking pot, you're breathing in smoking pot, the same stuff you're breathing in for the most part when you're smoking tobacco. Okay, so it's not healthier for you than smoking cigarettes. And then the people around you are getting the secondhand smoke, okay? And those chemicals are sorbing to, now there's not nicotine because that's specific to tobacco, but there's a lot of those other chemicals that are harmful to you are being produced from the pot smoke. So anytime you're burning something, natural gas is always comes up as an issue. Okay, so natural gas is obviously a cleaner fuel, but it still produces ultrafine particles and nitrogen dioxide. So if you're using gas burners, it's very important again to vent. But even if you're using electric burners, you want to vent your kitchen. So that's the particle stuff. Now, to answer your question about the low socioeconomic status, it was a talk. And I commend the organizers of the meeting because a lot of the controls that you or I might use in our homes that we think of as not so expensive might still be out of reach for somebody who's living paycheck to paycheck and is on housing assistance and really has very few financial resources. Okay, so and there aren't any easy answers there other than in general source control. So trying not to burn a lot of stuff inside your house, trying to ventilate when you're using indoor sources, and then if you have a specific issue like asthma, then trying to get resources through your physician or medical care if you have it to help control asthma, because you can do things for allergens and things like that. And I'm happy to talk more about it, but I've gone on for a while, and I also should let you guys ask another question.
I got a question for you. One of the things that caught my attention, and I don't know if I misunderstood or if it's something that's not as big of an issue as I thought, and I can't remember who brought this up, but essentially that particles change when they go from outdoors to indoors. And that I wasn't really that familiar with that. Can you expand on that a little for listeners?
Oh, yeah, it's fascinating. And it's both fascinating and actually somewhat relevant. So particles are very complicated. There are, when we talk about particulate matter, PM 2.5, another term would be aerosol. So aerosol is sort of the whole collection of different size and composition of particles, have both solid and liquid parts to them. They have a variety of different chemicals involved in them. They have water associated with them. And then some of those chemicals actually partition, or they divide themselves between being in the condensed phase. So the part of the chemical will be both in the particle and as existing as a gas around the particle. Okay. So and water is one of those chemicals. Okay, water is a chemical, and we always have water in gas form. We call it humidity, right?
Yep.
But then again, some water will be associated with the particle. So when you take the aerosol, which is this collection of particles that have different sizes and different chemistry and components, and you bring it from outdoor conditions to indoor conditions, you're going to change some of those features. So outdoors, if it's let's say it's the middle of the winter, right? Outdoors might be 15 degrees Fahrenheit outside, and indoors is a comfortable 70 degrees Fahrenheit. Okay, well, you've just heated everything up quite a lot. And that's going to change the amount that the water is going to be associated with the particles versus in the gas. It's going to change the amount that the other chemicals want to do that. And then outdoors might be 35% or 40% relative humidity, or even higher, 60%. But then when you heat up that air, then indoors is much drier in the winter. Okay, so changing the humidity in the air is going to change things. And then flip that in the summer. So all these chemistry things are happening. And then again, as you bring particles indoors, if you have that nice tight house, and let's say you have an exhaust mechanical ventilation system, so then you're pulling air in through the gaps and the cracks. Okay, and then as the air is coming through your nice tight shell, some of the particles are going to be removed, and they're not all going to be removed uniformly, right? Some sizes will be removed preferentially over others.
Right.
And then over time, those processes happen indoors. So the net result of that is, even if you have no particles indoors, your aerosol indoors that came from outdoors is going to look different, not just in the total amount, but in the characteristics of that aerosol. It's going to look different indoors than it did when it was outdoors. And we have a whole lot of fun studying this stuff. And the net result of it is, by understanding this stuff, we can better understand how to control it. Right? What controls are suitable for different situations.
Well, and I guess I don't know if this is maybe maybe I didn't understand this right, but then there's also chemical reactions with ozone and maybe with other chemicals indoors that are coming from paints or whatever that also change things to some degree. Is that accurate to say?
Yes, absolutely. So, and that's a whole other field of study, kind of the indoor chemistry.
Yeah.
And while we're on that topic, we talked a little bit about filtration. I want to just quickly note, in terms of new, research results you can use. What I will tell, one caution I want to give, which is that there's a lot of air cleaning systems that use chemistry in some way, shape, or form, right? So they're ionizing the air, and they talk about how creating ions is very helpful, or the worst
hydroxyls.
Yep.
Yeah, right. So the worst of it is when these ozone air cleaners, right? So they're producing ozone with the idea that you're going to react the ozone with all the VOCs to remove the VOCs, and that's going to produce some better, indoor air quality. In general, I would say people should be a little cautious about trying to do chemical experiments with the air in their home. So there are some chemistry-based air cleaners that can work very well, but if they're not working well, they can really do more harm than good. So it's sort of a generic caution that it's something I wouldn't generically recommend. I would recommend against trying to use some kind of an air cleaning device that's using some chemistry that you don't understand. And even if you think you understand it, be a little skeptical of it. Ask a lot of questions, okay? Certainly you should ask the questions of, what happens when this thing doesn't work right? How does it not work right? What are the hazards? How do I know it's working right? How would I know if it stops working right? Because there's, I think, not always good answers to those questions.
I think that's a great way to kind of wrap things up. I know you have to run, but we've got to get you back. I have another page of questions here we didn't get to. I'd love to get you back to talk a little more about this in the future.
Happy to do it. I'm big fans of what you guys do, and just let me know, and I'll be here.
All right. Is there anything real quick you wanted to add before we go?
No, I just want to thank you guys, and again, I want to real shout out to all the really hardworking people. I tell you, there's one thing, which is there's people in government often get a lot of criticism, but we work with people at the state level, the Air Resources Board, the Energy Commission, EPA, people at the Department of Housing, Urban Development, Department of Energy. There's a lot of really, really, really hard-working people who work nights and weekends to try to do their jobs well for the American people and for the citizens of the states they're working for. And just people should know that there's a lot of hard-working people out there who are really trying to do their job responsibly and use the taxpayer money well and do good for the people.
And don't always get enough credit for that. Well, thank you.
Thanks. Take care, guys.
I think that's a great way to end today's show, Dr. Brett. Dr. Brett Singer, that was fascinating and a lot of fun. Cliff, anything you'd like to add before we wrap it up?
Nope. What I'll do is I'll get the blog out, and then I'll let Dr. Singer put his, whatever links he would like to put on there on the blog.
Sounds good. So, folks, we'll be back next Friday. Actually, Cliff will be back next Friday with next week's episode of IAQ Radio. I'll be on the road. I'll try and join in, but it could be tough. This is Radio Joe Hughes saying thanks to this week's guest, Dr. Brett Singer. Of course, thanks to my co-host, the Z-Man, Cliff Zlotnick. John, you got to have faith at the controls. Most importantly, our growing group of loyal listeners. By the way, keep checking out those YouTube versions of our show. They work really well, actually, and we're starting to see some people looking at or listening to and now watching the show via the YouTube that we put up each week. The link to the YouTube version we put up each week on the website. So we'll be back next Friday at noon with the next episode of IAQ Radio.
This has been another IAQ Radio production.